All right, today's lesson is about mean and standard deviation. I know you've heard about mean before. Another word for that is average. I'm thinking that standard deviation for some of you will be new. So, stupid joke alert, in case you can't read it. This guy is saying, when she told me I was average, she was just being mean. Ha ha. All right, mean, you guys, so that you can know this, is another word for average. It is one of the measures of center that we talk about with different sets of data. And we'll talk about other measures of center in a minute. But mean is one of the major measures of center. And you guys know that to find the mean, you add all the values in the data set and you divide by however many numbers there are in the set, or by the number of observations. Okay? So here's what you need to know. The X with the line above it, that is the statistical symbol, which means mean. Okay? So the X with the line above it is the mean. So this is the mean right here. This symbol, which is called sigma, is the sign that means to add up. So what that is saying is that you are going to add up the x values, which are all the numbers on the list. Okay, so you're going to add up all the numbers on the list, all the x's, and then you're going to divide by n, which stands for however many numbers there are. Okay, so I know that you know how to find average, but you probably don't know the symbols used, the fancy-dancy statistical way to give the formula for mean. All right, I just quickly want to talk about some things that we have, some vocabulary words that we've used already, and then some that we will talk about today. Okay, measures of center that sort of describe the middle of a set of data. There's three words: mean, which is the average; median, which we've already talked about. That's where you list them in order from smallest to largest and find the middle number. Mode we haven't talked about much, but that is the most popular answer. We looked at that a little bit when we did histograms, and we talked about the peak. When we talked about the peak in histograms, we were talking about the mode. Okay? Then the different measures of spread. Spread basically is going to tell you how clustered your data is or how different your data is. If it's very clustered or your data is all very similar to each other, you are going to have small spread. If your data is very different from each other, then you're going to have larger spread. And some words that describe spread, or how clustered or not your data is, are range, which we know is the difference between the max and the min; the IQR, which is also interquartile range, which we also know is the difference between your Q3 and your Q1, or your 75th percentile and your 25th percentile. Standard deviation is what we are going to be focusing on today, and so I will talk about that a little bit more. It probably doesn't mean a whole lot to you right now, but it will. And then the 5-number summary is made up of the min, the Q1, the median, the Q3, and the max. And so those 5 things put together also give you a little bit of idea of spread of data. Okay? All right, so here is what is called a dot plot, okay? And these dot plots show some distributions of height of players on 2 hypothetical women's basketball teams. So one of the basketball teams is the Dolphins, and it gives you the height of some of their different players in inches, and the other team is the Sweet Peppers, and it gives the height of some of their players in inches as well. And as you look at this, I want you to think about which team do you think has more variety in the height of their players. And I don't know what you think, but my gut is to go with the red dot plots, the Dolphins. It looks like their players are a little more different from each other. And which team has the larger spread? That's kind of what we need to talk about, because there's different ways to measure spread. If you look at just the min and the max on both teams, you'll notice that they're similar. And so we're going to look at just some different pieces of data and talk about what we have to use when. What I would like you to do is I would like you to take your graphing calculator, and I would like you to put the Dolphins in list 1 and the Sweet Peppers in list 2. Okay, so enter, like for the Dolphins, you're going to enter 70, 71, 71, 73, 74, okay, in list 1. And then for the Sweet Peppers, you're going to put that in list 2. I want you to hit pause while you do that, please. In case you don't know, and this is on your note sheet as well, but there is some directions here for how to find standard deviation on the calculator, which we will get to in a minute, but I want you to know that it's on the back of your sheet. Okay? So what you're going to do is you're going to go to your calculators, and you're going to have your data here in list 1 and list 2, which I do, and you're going to use your calculators, and you're going to find the 5-number summary and the mean and the standard deviation and the range and some other good things about the two sets of data. Okay, so just a reminder that to do this, first of all, we'll find the 5-number summary and the mean. Those will all be on one screen. So I'm going to quit out of here, and then I'm going to go to Stat, and I'm going to go over to Calculate. And first of all, I'm going to hit number 1, and I'm going to do list 1, which is the Dolphins team first. And here's what you need to know. The X with the line above it right here is the mean. We're going to use the SX for the standard deviation here. Okay, so we're going to use the SX for the standard deviation, and I'll talk about which one would be which when. But the SX is the standard deviation. And then just a reminder that if you scroll down, the 5-number summary is down here. Okay, so we're going to clear our ink layer first, and we're going to go over here. Okay, so I think you can get the rest of this from here on your calculator. So find these things on your calculator, and then you can check them. Okay, so you can hit pause and check them and make sure that you've got the right answers right here. Okay, actually I'm going to go back to this screen. If we look at this, you guys, and we're trying to decide which team has more spread, the Dolphins or the Sweet Peppers, there's some different kinds of data that you can look at, okay? First of all, if you look at the range is one way to describe spread, and the range, again, is where you take your maximum value minus your minimum value. In both cases, that was 80 minus 70, and you can see that your range is 10 for both of them. And so that doesn't really give you any indication about which one is more spread out, the Dolphins or the Sweet Peppers. Okay, IQR is another way to measure spread. And it looks like the Dolphins have a spread of, or an IQR of 8, and the Sweet Peppers have an IQR of 0. So definitely the Dolphins have a bigger number, bigger spread according to the IQR. But what's puzzling about using that piece of data in this case is that the IQR here is 0. And 0 tells me that there is no spread or no difference in the data, in all the pieces of data in the set. Okay, and that's not true. There is, if we look back at that dot plot, the Sweet Peppers do have some variability in their data. So the spread should not be 0, so this is kind of a unique data set. Okay, so therefore, in this case, the very best way to describe spread in this case is to use the standard deviation. Okay, and we can see by the standard deviation that the Dolphins have bigger spread than the Sweet Peppers. Okay, so the Dolphins do indeed have more variability or more spread. Okay, so there's kind of key times to use the mean and the standard deviation and whatever. So I want you to notice this. If your data is symmetric, it is best to use the mean and the standard deviation to describe it. If it is skewed, it is best to use the median with the 5-number summary, and then you can kind of describe it with the IQR and the range. Okay? All right, we need to learn a little bit more about standard deviation and how you got those crazy numbers that we just looked at. What in the world do that 3.77 and the 2.40 mean about the Dolphins and the Sweet Peppers? How do you calculate it, and what does it mean? Okay, so standard deviation basically gives you an indication of the variability or the spread of your data. The smaller the standard deviation, the more clustered the data. And what it does is it measures the average distance of every single data point from the mean of that data set. Okay, and I'll show you some pictures that'll help you understand this in a minute. First of all, there are two kinds of standard deviation that we need to calculate. Okay? One of them is where only a sample of data was taken. And I actually am not quite sure whether a sample or the whole entire team was used in this dolphins and sweet peppers thing. But I'm going to assume that it was just a sampling of their team because I'm thinking there's maybe more than 10 players on a team. I'm not sure. But we're going to think it was a sample, okay? So when you only use a subgroup of the population or a sample of the population, then you're going to use the SX for standard deviation. And when you use the entire population in a data set or a situation, then you're going to use the population standard deviation. And the population standard deviation is indicated by this symbol right here, okay? That's the only difference. The SX is when you used a sample in your data set, and the population is when you use the whole entire population. All right, so let's talk a little bit about how standard deviation is calculated and what it means, okay? So here I have a set of dogs. Not very many dogs because I want to make this illustration simple so that you can understand it. But here is a set of 5 dogs. And what we did is we measured the height of those dogs to their shoulders, and we measured them, as you can see, in millimeters, okay? So there are some taller dogs and some shorter dogs and whatever, but we measured how tall the dogs were to their shoulders in millimeters, okay? So that's what that first mark means. Then what I did is I found the average height of those dogs. And again, to find the mean or the average, you add all of the numbers up and you divide by however many numbers there are. In this case, there's 5 dogs, so I divided by 5, and I got an average of 394. And then what I did is I just put that green line there on my graph so that you could see where the average was. And clearly you can see that there are dogs that are taller than the average. You can see that there are dogs lower than the average. There is no dog that is exactly the average height in this data set, but that is not unusual. Okay. Then what you do is you take each dog and you figure out how far away it is from the mean. So that first dog was 206 millimeters above the mean, and then there's a dog that's 224 millimeters below the mean. Okay, so you measure how far each one is away from the mean. And then you square those distances. And then you divide by 1 less than the number of numbers there are. So in this case, again, there was 5 dogs. And so I squared the distances here. And then I added them all up to get this total, which I then brought down here. And there was 5 dogs, but I'm going to divide by n minus 1, which means I'm going to divide by 1 less than the number of numbers there are, so I'm going to divide by 4 in this case. And then I get this number, which is called the variance. At this point, that's called the variance. And if you were in AP Stats, we'd be talking a lot more about that, but we're going to leave it right here. Okay, then you find the standard deviation by taking the square root of that variance number. So the square root of the 27,130 is 164.71. So that's the standard deviation in this case. And what that means is one standard deviation away from the mean is a distance of 164.71. So this distance right in here is 164.71 millimeters in this case, okay? We will learn a little bit more about this later, but what you need to know is that in a normal set of data, 68% of the data will fall within 1 standard deviation above or below the mean. So if you, and this is hard to see because we have a really small data set, but basically 68% of a normal data set will fall within 1 standard deviation of the mean. That means they'll fall here. Okay, now, do you sometimes have data that is kind of exceptional? That is, in this case, a dog that would be extraordinarily tall or exceptionally short. Is that going to happen sometimes? Absolutely. Okay, and you can see that in these dogs. This dog right here happens to fall out of that range of 1 standard deviation above or below the mean. That means it's an exceptionally tall dog. This dog down here happens to fall out of the range also, but it is exceptionally short. Okay, so what's going to happen, and I know it's hard to see because this is a small data set, but most of your data is going to fall within one standard deviation of the mean. If it's outside of that, that means it's sort of an exception to the rule, or it's not necessarily an outlier, okay, but it means it's an unusual case. All right. What you need to know is, and here's the 5 steps, the long way to calculate standard deviation. I got to tell you, we're going to use our calculators to calculate standard deviation, and I already showed you how to do that. You're going to calculate it the same way on your calculator that you did the 5-number summary, but then you're going to just look for the sample standard deviation or the population standard deviation. But what you need to know back here is this. The smaller the standard deviation, the closer together these 2 blue lines will be. Okay, the smaller the standard deviation, the closer the 2 blue lines will be together, which means that the more similar your data is. The bigger the standard deviation, the farther apart the 2 blue lines will be, and the more spread out your data is. Okay. It's kind of hard to measure whether your data is really close together or really more spread out with just one standard deviation. You kind of need 2 sets of data and then compare their standard deviations a little bit to say whether one is more spread out than normal or not or whatever. And we will look at that in future days. But that is how you calculate standard deviation and a little bit about what it means. Okay? So that should do it for today.